So we get into the third one now, which is called fast glycolysis. Now, these first three, they're all anaerobic. Anaerobic basically means that this process happens with no need for oxygen. So, you know, sometimes you do a very short session, maybe short interval-based work, and you'd be going max effort, and then you stop, and then suddenly you realize you're breathing hard. And you weren't breathing hard during the exercise itself. Like, let's say you're doing a 100-meter sprint. You sprint 100 meters, you don't get 80 meters in and think, I'm out of breath, I need to slow down. You get to the end, and then it's hands and knees, then you're exhausted. Because the actual exercise itself was anaerobic, not using oxygen. Which is good because we don't have to breathe fast, we can create a lot of energy in a short amount of time, but you can't hold your breath for longer than about 100 meters, so it's not effective for the long term. This fast glycolysis, this is now starting to get to the point where there are some negative byproducts. And these negative byproducts slow down the production of energy. Who's ever had that lactic acid burn? Everyone put your hands down. No, you haven't. It's not lactic acid. You walked right into that one. The enemy is not lactic acid. Basically, decades ago, they did research into goats. And they put goats on treadmills and exercised them until they collapsed. And then they cut them up, looked at what was happening in their muscles, and saw these really high levels of lactic acid. Therefore, correlation implies causation. Lactic acid equals exhaustion. This must be a bad thing. That's no more a bad thing than saying someone is exercising hard, they start to sweat, therefore sweat must be a bad thing because it's associated with high intensity exercise. Of course, it's not the case. Sweat is there to help to cool our body temperature, to increase our ability to exercise at intensity. So is lactate or lactic acid, depending on what stage of the cycle it is. That's not the enemy. The enemy here are hydrogen ions. And that's the result of high intensity exercise performed anaerobically. So very, very high intensity for a short amount of time. Imagine you're doing a hill sprint. You start at the bottom of the hill or like a prowler push. You start that sprint and you get to the point where your legs stop working. You still want to work hard, but they're burning so much, you're telling them to work, but they refuse to. It's not a mental thing. They start to shut down. Has everyone experienced that? Yeah? They just won't go anymore. What's happening is your body is producing these hydrogen ions. These hydrogen ions are the byproduct of high intensity exercise. They flood the system and they actually inhibit the production of energy. Because if you keep exercising at that intensity, just like those goats that collapsed on the treadmills, you will die. Because your body is poisoned by acid, effectively. That's the acid burn that you feel. So our body says, okay, we have to stop, we have to back this off, because when given the choice of running slower or dying, we're going to choose running slower. Because remember, from an evolutionary perspective, our bodies have evolved to try and survive as long as we can. You're trying to run away from a predator, but it gets to a point where you will definitely die if you keep producing this acid. If you slow down, at least you've got a fighting chance, literally, against the saber-toothed tiger. So, you exercise at high intensity, your body produces these hydrogen ions. They cause muscle acidity, which is that acid burn that you feel, and then it causes an inhibition of fast glycolysis. So, it stops this process happening so you don't die. Those are our three anaerobic energy systems that we're talking about. Stored ATP, what's in there already, phosphocreatine, and fast glycolysis. This would be maybe a 20-meter sprint, a 100-meter sprint, maybe a 400. Okay? Which is exactly why that 400 meters is so painful. Okay? Now, can you see that if we could make this point kick in, this point where our body starts to inhibit this process, if we could make that happen at 450 meters instead of 400, then we're more fit. Does that make sense? Yeah? So someone who hits what's called the anaerobic threshold, which we're going to talk about a lot in a moment, someone who hits the anaerobic threshold in 60 seconds of sprinting is going to be fitter than someone who hits that threshold in 50 seconds of sprinting. Someone who can last 2 minutes before hitting the wall, before being inhibited, is a lot fitter than someone who packs up at a minute. Does that make sense? And each of these thresholds, each of these points is exactly the same. If we can raise the threshold, it means you can work at that higher intensity for longer before you start to hit the wall. Do you see how that is absolutely fundamental and key in increasing performance? And the equation becomes really simple. We just push each threshold further down the running track. If we can do that, we improve our performances. And that's what we're going to talk about in this lecture in a moment, is how we actually push those thresholds higher.